So, last section we'll take a look at is 1.6. And this section is on basically taking two functions and combining them together to create a new one. Let me just show you a couple different ways that you can do it. So the basic way to take two functions and combine them is either add, subtract them, multiply them, or divide them. Okay, let me show you a really simple example. Let's say we had this function. F of x equals 3x. And we had g of x equals 2x. And I said to you, I want you to create a new function from those two by adding them together. So I would write that down like this. And then I would ask you what that would be. What do you think the function would be here if you added f of x and g of x together?
5x.
5x, yeah. So what we did is we just created a new function by adding the two that we had together. Now, sometimes when you try to add them up, they're not like terms and you can't add them. Like if f of x was x squared and g of x was 4x, and I said to add those up, well, when you add them, it's just going to look like this. There's nothing else you can do because they're not like terms. But those were like terms. Any question on that? All right, try another one. But here's two functions, kind of like I just did actually. F of x is x squared, and g of x is the square root of x minus x plus 1. Are these like terms? No. To be like terms, you'd have to have like x squared and 2x squared. Something like that. But that one's an x squared, that's a square root. They're totally different. So, if I take and add them up, what would it look like underneath that box when I add f of x plus g of x? What do you think is written right there?
X squared plus square root of x plus 1.
Yeah, that's all you can do. It's x squared plus the square root of x plus 1. So that's a new function created by taking the two that we had and adding them up. Okay. Let's try dividing them. All right. Well, Zach, what's f of x again?
3x.
So in this example, whatever example this is.
X squared.
Yeah, x squared. And what's g of x?
X squared. No. Square root of x plus 1.
Square root of x plus 1. So what I want to do now is divide them. Take f of x and divide it by g of x. Now, when you divide them, you end up with this. So the step we just did is okay, but you're not supposed to leave an answer like that. What's wrong with how we left that answer?
What I missed, why did you divide them?
Because that was the question. It just said to take the two functions and divide them. So they told us to do that. But why don't we want to leave the final answer like that? What's wrong with it? Yeah?
Because actually, can you have a square root on the bottom? Or
No.
Okay, yeah.
You can't, you're not supposed to leave the square root on the bottom. So to fix that, you multiply the top and the bottom by the same thing. What you multiply the top and the bottom by is the square root that you're trying to get out from the bottom. Just like this. Okay, you got to do the same thing in the top and the bottom. Now in the top, when you multiply those together, nothing happens because those aren't like terms. You can't combine them. So it's just multiply straight across. X squared times the square root of x plus 1. But in the bottom, something happens. The square root of x plus 1 times itself. It's basically like doing this. You're multiplying it by itself or raising it to the second power. So what's the square root of x plus 1 times the square root of x plus 1? Yep.
X plus 1.
X plus 1, that's the whole reason we did it. It got rid of the square root. So here's another example of creating a new formula by taking two that you already had, and in this case, dividing them. Any questions on how we divided those two? And you could subtract them, you could multiply. There's all kinds of different things you can do, and there's more examples in the book on page 58. Okay, so now, what we want to look at is once we combine them together, okay, this function had a domain when we started the problem. This function has a domain. When you take the two and combine them together, what's the domain of the new thing that you created? Okay, that's what we want to be able to figure out. And that is how you figure it out. So the domain of the new function that you made is all the numbers that work in both of the original functions. Okay, if you're more of a visual person, think of it like this. That circle represents all the numbers that work in f of x. This circle represents all the numbers in the domain of g of x. The domain of the new function is the overlap. It's the numbers that are in both the green circle and the red circle. It's the numbers that work in both functions. Now, one thing we do have to be careful about, it doesn't really come up with addition, it doesn't come up with subtraction, it doesn't really come up with multiplication. It comes up with division. What's something we would have to be careful about in this problem, especially looking at the bottom? What do we not want to have happen in the bottom? Yep.
We don't want the bottom to equal 0.
We don't want the bottom to come out to 0. So that means you could not use what number there? Yep.
-1.
Yeah, you couldn't use -1. Now, look at the original problem. You can plug -1 into the original. You can take -1 and square it. That's fine. You can take -1 and plug it in right there. -1 plus 1 is 0. And the square root of 0 is 0. So you can use -1 in the originals. But the problem is when you combine them together the way we did here, all of a sudden -1 messes you up because you'd be dividing by 0. Okay? The original problems didn't have fractions in them. The final answer does. All right? So that's one thing we got to be careful about when we create a new function. If you create one that has a fraction, make sure the denominator is never 0. Okay? If it could be 0, you need to tell me what numbers I shouldn't use. We don't want it to be 0. What else don't we want to do? We never want to divide by 0. And the other thing I keep mentioning is we don't want to take the square root of what kind of numbers?
Was it negative or not?
Negatives. Okay, we don't want to take the square root of negative numbers either. Those are the only two problems we got to make sure we avoid. Dividing by 0, square roots of negative numbers. Okay, so just remember those two things.
Do you know if I have any fire drill today?
No, I don't know.
Where'd you get that from? Mom or from?
That's what I was going to say. I was just curious. Mr. Hager's all powerful and knowing.
I don't know everything. Okay, so This says to do something. We're going to do something in a second. We're going to take these two functions and combine them. I haven't shown you how we're going to combine them yet. Before we combine them, though, let's just write down what the domain is for each one of them. They both have square roots. What did we just say? We never want to take the square root of what? A negative. That means you always want this to be 0 or higher. 0 or higher. Think of it like this. You need what I just circled to come out 0 or higher. So what does that mean you could plug in for x? Like you couldn't plug in -10. That's too small. -10 plus 3 is -7, and you'd be taking the square root of a negative. We need x to be what?
Anything greater than or equal to -3.
Yep. Anything greater than or equal to, that's the bracket. And he said greater than or equal to, which means you can go as high as you want. As long as you pick a number -3 or higher, this will never come out less than 0. Okay. How about this bottom one? What numbers would you have to pick for x to make sure that x minus 2 is never a negative number? We need x minus 2 to always be 0 or higher. Yep.
2.
2.
Positive, like, what do you mean?
So what would your domain be?
Your domain would be 2 comma infinity.
Yep, 2 to infinity, including 2.
I forgot, what's the rule with the brackets and the parentheses? I remember they were important, so I forgot what.
So the bracket means you can include the number. The parenthesis means you cannot.
Okay.
But it's perfectly fine to include 2 because you can take the square root of 0. I think people mix up square root of 0 and dividing by 0. Square root of 0 is fine. Dividing by 0 is not. All right. So now let's take these two functions and create a new one by adding them. They're not like terms. Square roots that are like terms would look like this. Here's an example. If you had the square root of x plus another square root of x, that's 2 square roots of x. But these have to be the same to combine them together. These are different. X plus 3, x minus 2. Okay. Okay, so let's combine these functions together by adding them. They're not like terms, so literally just write down exactly what you see. That's f of x plus g of x. All right, now what I want to know is the domain. So remember when I drew the circles, it was the overlap. Think of these two domains as pictures. Here's -3, here's 0, here's 2. The top one had a domain from -3 going up forever. The bottom one has a domain of 2 going up forever. The domain has to be numbers that work in both of the original functions. For example, if you plug in 0, 0 works here because 0 plus 3 is a positive value. But 0 doesn't work here.
So it's the lowest possible number, like 2?
So yeah, what do you think the domain would be in this one?
2.
2
Infinity.
to infinity. Yep.
2 infinity.
Domain is 2 to infinity. It's the numbers that work here and here. Has to work in both. Let's take same thing, except now let's divide them. Okay. All right, now we're going to take f of x and g of x and divide them. Okay. Someone remind me, what was f of x?
F of x was -2, was it?
Yeah, square root of x plus 3. Okay, what's g of x?
Square root of x minus 2.
Square root of x minus 2. Okay, so there's our function when we divide them. Now I want to know the domain. Now, just be careful.
Don't we have to do that?
Oh, fix it so the square root isn't in the bottom? Yeah, we could fix that. So multiply by the square root of x minus 2 on the top, and multiply by the square root of x minus 2 on the bottom. Yeah, technically that is the proper way to leave it. All right, now the domain. We already know the domain of the original. We also already know the domain of the overlap. So would the domain of this one be the same? Every number from 2 to infinity.
No, because you can't have 2 on the bottom.
We can't use
Or
the
you can't have
2.
0 on the bottom.
Yeah, we can't have 0 on the bottom, so we can't use the 2. So the domain would be very close to this, but what would change?
2.1.
What about 2.05? You could still use that one. Yeah,
The bracket's gonna change to the brackets.
yeah. So what that means is the lowest number you can pick is 2, not including 2. So it's like 2.000000001.
So you can use the highest number you can do is infinity, not including infinity.
Yeah, because infinity you can't reach. There's no way to reach it. When you put a bracket on something, that means you can include and reach that value. But infinity, you can't reach. Because whenever you think you're at it, you can always go one more, and then now you're higher.
So with the parentheses, you can go higher? Or not?
So parenthesis means not to include the value.
Okay.
So in this case, the domain is every number greater than 2, not greater than or equal. Greater than 2. Okay, so small change, but it's pretty important whether you put a bracket or whether you put a parenthesis. Any question on that one? Okay. All right, here's another one. This time it says to graph and then find the domain and the range. All right. What does it tell me to use for f of x?
Absolute value of x.
So that goes in the top. What does it tell me to use for g of x?
Wait, why is it 1 times
Oh, I did not know why it's 1 times 1. Why is it 1 times 1? Oh no, that's not 1 times 1. That's the absolute value side.
Oh, I was like, what?
I was like, why is it 1 times 1? And then g of x is x.
And g of x is x.
How did you find that out?
It says it.
Oh, I didn't
So they give me the two functions,
I just didn't see that.
and here they said to divide them, so I just filled them in. All right, are there any square roots in that formula in red? No. So we don't have to worry about that. Are there any fractions with variables in the bottom?
No.
There's no fraction in that red box?
Oh, yes, there
The
is.
whole fraction.
Yeah, is there a fraction with a variable in the bottom?
Yeah.
Yes.
Yeah, then we could divide by 0, so we need to make sure we don't. What number are you not allowed to use for x right here?
0.
Hey, can you use anything lower than 0?
Yes.
Can you use anything higher than 0?
Yes.
Yes.
So the way we're going to write that, anything lower than 0 means you can go as low as you want, and you can go right up to 0, but don't include it. That's why there's a parenthesis. We don't include the 0. Or, how do you think we would write, we can pick any number higher than 0?
0 with the parenthesis.
Mhm.
And And then infinity.
comma, infinity. Yep.
What does the little u mean?
This means or.
Okay.
So you can pick a number lower than 0 or higher than 0. All right. Let's draw that and see if we can figure out the range. So absolute value, if you don't remember where that is, it's under math, number, absolute value. So absolute value of x divided by x. Does it look like this graph goes up and down forever?
No.
No. In fact, it only looks like it ever hits two values. What are the two numbers that it looks like it hits in the range? Right. And if you plug a number in for x, like let's say you plug in 5, what's the absolute value of 5?
5.
And what's 5 divided by 5? 1. No matter what positive number you plug in, you're always going to get 1 as the answer. Now, try a negative number. What's the absolute value of negative 2?
2.
2. What's 2 divided by negative 2?
Negative 1.
Negative 1. So any negative number you plug in comes out to negative 1. So for the range, we're going to literally write every number that's in it, because there's only 2. 1, negative 1. Usually we can't list every single number that's in the domain or the range because there's too many of them. Like here, anything greater than 0. How are you going to write down every number that's greater than 0? You can't. So you have to do it this way. Well, that's it. That's the domain and range. Questions on that one? So adding, subtracting, multiplying, dividing. That's one way you can take two functions and put them together. The last way I'm going to show you is what's called composition. So it's another way to take two functions they give you, and we're going to put them together. We're going to do the same kind of thing we did before. I'm going to ask you about domain and range. Okay. First, I'm going to show you how you just put them together. Then we'll worry about the domain later on. Okay. So first of all, the notation. This is what it looks like when they want you to do a composition. Usually you see a couple letters there. G, and then each parenthesis, you read it like the word of. G of f of x. Now, what if I wrote this? G of 9. How would you figure out what G of 9 is using the formula that's on the board?
You'd put in 9 for G of 9.
Yeah, you take the 9.
Well, you figure that X is 9.
Right.
So then you fill in 9 for all the X's.
You fill in the 9 for all the x's in that formula. This particular one has nothing to do with f. Right? So you'd fill in 9 for all the x's right there. All right. So let's try to figure that out. G of f of x. Okay, start by just telling me what this is. Okay, so it says G of, I wrote 9 up above, it's not going to be a number this time. What does it say f of x is?
X squared plus 3.
So then let's change that to what it says it is, x squared plus 3. That's the first step. Change f of x to what it tells you in the formula f of x is. Now you're going to do the same thing here that we did up here. You're going to take whatever you have here and you're going to fill it into function g everywhere there's a letter. So in function g, everywhere you see a letter, I want you to change it to what's inside those parentheses. if you plug in x squared plus 3 for the x right here, what would it look like?
G of x, or G parenthesis square root of x squared plus 3.
So you'd have the square root of x squared plus 3. If you plugged a 9 in here, you'd have square root of 9.
Wait, I'm wrong.
If you plugged like a 5 in here, you'd have square root of 5. We're plugging this in for the letter
Oh.
right there. So instead of x, you're going to
Oh.
fill in x squared plus 3. And that doesn't simplify. That's all you can do. Right, let's try another one. Same idea, but we're going to switch it. Instead of the G on the outside, now it's on the inside. So leave the letter that's on the outside and look up what this is.
Square root.
It says it's the square root of x.
Where'd you see that?
So g of x is the square root of x.
This is all part of the problem. It's like this is not actually the equations, right? Like G of x is not always square root of x.
No, g of x isn't always square root of
This
x.
is, this is just like what the problem is giving us to.
Yeah, g of x might be might be something different. Like f of x might be x plus 3. It might be square root of x. Yeah, it might be different. Okay, so g of x in this problem is square root of x. Now you're going to take this and you're going to plug it into function f. Okay, so look at function f. Everywhere you see a letter, change the letter to square root of x.
So it'd be square root of x squared plus 3.
Yep. So in function f, everywhere we see a letter, we're going to change the letter to what they're telling me to plug in. Most of the time they tell you to plug in a number. This time they're telling you to plug in this. So it's going to be the square root of x squared plus 3.
And that's it.
And what would happen when you square in square root here? Yep. I didn't want to cancel it out right away because I wanted people to see that step first. Any question on that?
The x, so the square root of x plus 3 is what we had above, and now we're bringing this.
We had x squared plus 3 up above.
Alright.
Yep. We'll try another one. But what I want to look at is once we combine them and you get this final answer, what is the domain? Okay. There's 2 steps to figure out the domain. When you combine functions with composition, there's an inside function and there's an outside function. The inside function is the one that's in between the parentheses. The outside one is the one that's in front. So you start by looking at the inside function. Look at that inside function and say, okay, is there any way I could divide by 0? Is there any way I could have a square root of a negative? If either one of those things can happen, you need to eliminate the values that would make that happen. I don't want to take the square root of a negative or divide by 0. So we'll eliminate any values that would cause that to happen in the inside function. Then we do the same thing again, except now you look at the final answer. Let's see. Does the final answer have any square roots in it? Does the final answer have any fractions where the variable in the bottom? If it does, we need to make sure that we don't take the square root of a negative and that we don't divide by 0. And we're going to do like 3 or 4 examples. And we'll do more with the composition. So if you're still not sure like how to do that, we'll practice. Okay, so there's the 2 functions we're going to use. Okay, I tend to use the square root a lot because that's the one that can, you got to be careful with. That's why you're seeing it pop up a lot. All right. Okay, the first thing they want is f of g of x. What function do we start with, the inner or the outer?
No.
Inner.
Yeah, so step 1, we're gonna look at the inner function. So we're gonna start with that. What is the inner function? I know the name of it is g, but what is it?
Square root of x.
Square root of x. So then change that to what it says it is. Now, everywhere that you have a variable in the f function, I want you to change the variable to square root of x. So you're plugging this in for the letter right there. So if we did that, what would we get over here?
Square root of x plus 1.
Square root of x plus 1. Yep. Let's try it again. Okay. Which function do we start with? The outer one or the inner one?
Inner.
Yep, inner one. Which one is the inner one in the bottom? G or F? F. What does it tell me up above f of x is?
X plus 1.
X plus 1. So now in function g, I want you to take and replace all the variables in function g with what's inside the parentheses.
Square root of x plus 1.
So would it be the same thing we have up here?
No. Everything's in the square root.
Everything's in the square root, yeah. So that is different. Yeah. Okay, so the point here is f of g and g of f, they usually don't come out the same. They might look kind of close, but they're not the same. Yeah, any question on that one? All right. Let's try another one. And this time, we'll do the domain with it. Okay, in the book, they have another way of writing this f of g and g of f. I don't ever write it the other way, but just to show it to you in case you see it, if you see a g, or if you see a letter, a little circle, and then another letter, this means exactly the same thing as what I wrote below. Okay. The way I wrote it below is how you'll always see it on like a test. Okay, so again, that's the way that you'll always see it. So G, and now without me kind of saying as much as I was, can somebody tell me what's going to go inside there? Yeah, now
X squared minus 1.
x squared minus 1. Okay, that's the first step. Now, second step is to take that and fill it in for the letter in G.
Would it be the square root x squared minus 1?
Yep, and you can't simplify it. That's as much as it does. Any questions on that?
I'm just confused on that last step. How'd you, on the very last thing you did?
So you took this
Yeah.
and you filled it in right there.
Um,
Like if that was a number, like let's say it was 9, I would normally take 9 and plug it in right there and do the square root of 9. Since it's x squared minus 1, I'm going to do the square root of x squared minus 1. Okay, domain. Eliminate any values that don't appear that would mess up the inside function. This is the inside function, f of x. Are there any square roots in f of x? No. Are there any fractions with letters in the bottom? Not for f of x. Nope. So from step 1, nothing gets eliminated. The domain is still all real numbers. Now we look at step 2, the final answer. Okay. Does the final answer have a fraction with a letter in the bottom?
No.
No. Does the final answer have a square root?
Yes.
Yes. What's under the square root, we have to make sure that what's under the root is always what number or higher?
0.
Yes, we always have to make sure that it's 0 or higher. Another way to think of that is when you square x, it has to be 1 or higher. So what kind of number can you square and it comes out 1 or higher? Well, if you squared like 1.3, that would still come out higher than 1.
Everything greater
Greater than,
than 1. Or equal to 1.
equal to 1, yep. If you take any number that's greater than or equal to 1 and you square it, it will come out bigger than 1. What other numbers can you square and they'll still come out bigger than 1?
I don't know.
What kind of negative numbers? Can anyone be more specific about exactly from this to this?
Negative 1 to infinity.
Negative infinity, yeah. If you square a number like negative 3, that comes out to 9. That's bigger than 1. Okay. Anything from negative 1 down or from 1 up. What this basically means is you cannot pick a number between negative 1 and 1. Okay? Like 0. If you square 0, that's not bigger than 1. That doesn't work.
What did you do the range for this?
No, not this one.
Oh.
No. Okay, so that's g of f. Now let's do f of g. So I'll look up g. It says g of x is square root of x. And now fill that into f. Alejandro, what do I get when I fill square root of x in to function f?
I don't know.
Okay, what is function f? It'd have to be something you already wrote because it's off the top of the screen. Can you even help him out? What's function f? Natalie?
Function f is x squared minus 1.
Yeah. F is x squared minus 1. So you're going to take this and you're going to fill it in right there. What do you get if you fill that in but don't simplify it? Just leave it for now.
The square root of x squared and then u minus 1.
Yep. Okay, now I want to simplify it. What happens when you square and square root? it cancels out. So that's our function. Now I want the domain. If all you did was look at that final answer, you might say, oh, there's no square roots, it's just x minus 1. There's no fractions. It's all real numbers. But remember, that's not how you find the domain. That's only step 2. Step 1 is to go back to the inside function. What's the inside function in this one?
Square root of x.
Square root of x. And we're only allowed to take the square root of what kind of numbers? Positive and? No, not reals. You can take the square root of positive numbers and what else can you take the square root of that's not positive? 0. Yeah. So all you can plug in the inside function is numbers 0 and up. Okay? 0 and up. Any question why you can't plug negatives in for the square root of x? Yeah?
Because then you get an imaginary.
Yeah, then you get imaginary. We don't want that. Okay? So the inside function limits us 0 and up. How about the final answer? Any square roots in that? No. Any fractions? No. So in this case, step 2 doesn't add anything new to the problem. There is nothing that you need to exclude from step 2. It all came from step 1. 0 and up. And because we're including 0, what symbol do you use? Bracket. So you can plug in any number 0 and up. Any question on the domain before we try one with range? Not going to do as many because we've done a lot with domain. So, any question before we look at the range? Okay. So range. Well, we're going to use the calculator, but before we can use the calculator, we need to set the window. If you don't know the domain, you're not going to be able to set the window. So to find the range, the first step is find the domain. After you find the domain, you're going to graph it on the calculator. We're not going to do both. I'm just going to do one of them. Let's do the first one. And I think that'll be the last one we do, and then the homework. Yeah. Okay, so graph and calculator, that's going to come up right now. Okay, so we're going to do G of F. Okay, there's no particular reason why I'm skipping the second one. I'm just skipping it. It's not harder or anything. Okay, so G of F. Okay, which function do we start with, the outer or the inner?
The outer.
Inner.
Inner. Okay, always start with the inner. What is the inner function here?
Square root of x.
Yep. So we're going to change what it says the name of the function is to the actual formula. So f of x is the square root of x. Now we're going to take square root of x and we're going to fill that into which function now?
G.
G, everywhere you see a letter.
So it's a
Square root of x minus 3.
So square root of x minus 3. Yep. You just change this to that. Okay, so there's that part and the domain.
Wait. Okay.
Okay. Inner function was square root of x. Are there any kind of numbers you have to be careful about filling in for x right there?
No.
Yes.
0.
So what
Three.
kind of numbers are we allowed to take the square root of?
3,
0 and positive numbers. So what would you be able to fill in for x here to make that happen?
Zero.
Equal to or less than 3. Or sorry, equal to or
What
greater
is,
than.
hold on a second.
Zero and up.
0 and up. Yep. You can plug in any numbers 0 and up here. Now check the final answer. Are there any square roots in the final answer?
Yes.
Yep. What kind of numbers would you be allowed to fill in right there?
0 and infinity.
It's also 0 and up. So it's the same restriction. Doesn't add anything new. So the domain is every number from 0 and up,
Including 0, right?
including 0.
Alright.
Yep. If it didn't include 0, I probably would have said something like every number above 0 rather than
Yeah.
0 and up. Yep. Okay, range. Need the calculator. So type in the square root of x minus 3. Okay, so square root of x, make sure the minus 3 looks like this outside.
How do you do that?
So once you type square root of x,
Yep.
press the right arrow,
Oh, okay.
and then you can type minus 3. If you don't press the right arrow, it's going to be under.
Yeah.
Okay, so domain, 0 and up. So on your window, we're not doing negative 10. 0, and it goes up forever. So, I mean, just go up to 100 if you want. And let's hit graph. So we're looking for how low and how high this function is going to go. If you can't see how low it goes, I can do zoom 6 and zoom back in, and you'll see it a little better. How low does it look like the function goes?
Negative 0.
So negative 3, yep. And how high does it look like it's going to go?
Forever.
Yeah, it just keeps going up and up and up and it never
Could
stops.
you show me your y equals then?
So the lowest was what number?
Negative 3.
Negative 3. And the highest?
Infinity.
Infinity.
Hey, but I have a question with, I can, like, how do you get the 3 out of the, so I should write the square root of, like 3, is that parentheses like that?
Yep, that's the same thing. Yeah, that's how yours is going to do it.
But I did that, I did x minus 3. but-
X and then close your parenthesis
Oh.
and then do minus 3.
There we go.
All right, any question on that one? So range is sometimes it's a little different, but you get the calculator to help you. So, and we'll be practicing that domain and range pretty much every chapter. We do something with it. Okay, let me see. Last thing. So yesterday we looked at all those different transformations, shifting up, down, left and right, and we applied them to quadratics, okay, y equals x squared. But once you know those transformations, they apply to every function we're going to study all year. So like if you have this, that's a square root function shifted up 3. That's a parabola shifted up 3. Okay? It's the same thing. It has added a number on the end. So what I'm going to do is give you guys a formula and see if you can tell me what the transformation is. I'm going to use some different letters. All these letters are going to be positive real numbers. Okay, so I think I showed you that symbol last week. Okay, so I'm going to use some letters, and these letters represent positive real numbers. start with the first one. When you take and multiply by a number in front of a function, like we did this yesterday, multiply by a number in front. What does multiplying by a number in front do? Does anyone remember the transformation? Well, what would this 3 do right here? Was it a stretch or was it a shift? Yep,
Stretch.
that's a stretch. Yep, and what kind of stretch?
By the factor of 3.
Which way?
Vertical.
Vertical. Yep. So that is the formula for a vertical stretch, or it could be a shrink if A was a smaller number. Multiplying by a number in front, that's a stretch or a shrink vertically. How about adding or subtracting a number at the end? Does anyone remember what that does?
Shift it left to right.
It is a shift. But when you add or subtract the number on the end, it's a shift.
Horizontal.
No, not horizontal. This one is a shift. It's vertical. And when you add or subtract the number on the end, that's a vertical shift. So something like this. X squared plus 3, that's a shift up 3. How about if you add a number inside the parentheses? What does that one do? Yep,
You think of horizontal,
that is a horizontal shift.
left.
Left, yep. How about if you subtract a number inside parentheses? Which way does that move your graph? Yep,
Right.
yep, it's going to move it to the right. And then the last two are when you have a negative. Okay, I'm not worried about which one does what right now, but does anybody remember in general what a negative does to the graph? Takes the graph and it does what?
Doesn't it compress it?
So this one, it could compress it if you had a number other than like a 1, like if you did a 1/2
Yeah.
in front, but just a negative without a number, just a negative, does what? Yeah, it reflects it. Does anybody remember which way the negative in the front reflects it? This is the one with the parabola where we could actually see what it did.
And just
Reflected it over the,
y-axis.
The x-axis?
well, when it reflected over the y, we couldn't see it because it was symmetrical. Reflected over the x-axis. So a negative in the front reflects it over the x-axis. How about a negative on the inside? Yep,
Reflected over y.
that reflects it over the y. Yep. So using that table that we just did up above, I want to see if we can draw this picture. And I'm going to take that picture and I want to do that to it. And this will be our last question. So the first thing we have to know is what is each of those numbers doing? And we can look that up right there. Okay, so we have a 2, a +1, and a -3. There's 3 transformations that are going to happen in this problem. So 3 things are going to happen to that picture in black. When you do transformations, does the order matter?
Yes.
Yes, and I gave you that order yesterday. So we have to follow that order. what number are we gonna focus on first here? The 2, the +1, or the -3? So that requires you to identify what each one of these numbers does, and then look at the order from yesterday and see which one comes first. Okay, well, what's the 2 gonna do? Let's just read them left to right. That's a number that's in front. Well, Brett, what's the 2 gonna do? Okay, you have the chart written down? Okay, I would definitely, again, if you don't know some of this stuff, these tests are gonna be brutal. So you really, because you can make a reference sheet on all your tests too. So if you write it down, you'll have good stuff to put on your reference sheet. James, can you help us? What's this multiplying by a number in front? What's that gonna do?
I believe that's the vertical, like the vertical shift.
No, vertical shift is when you add or subtract a
No,
number on the
stretch
end.
shrink.
Vertical stretch, yeah. Okay, so that's gonna be a vertical stretch. Okay, so we know that first one. How about the +1? What's that +1 gonna do? Look for it up there and see which one looks the most similar.
Horizontal shift left.
Yep, so we got a shift left. And what about the -3 on the end?
Then that's going to be a change in the y-axis down 3, right?
Shift down 3. Yep. So we know what the 3 transformations are. Yesterday we had the order. What's the first one we have to do? Yep.
Stretch, right? No, vertical shift first, right?
Vertical shift is always last. That was the 4th one. First thing we always do is the step 1 said horizontal shift. That's the first one. I'm just gonna make that red.
Stretch shift
And which way did we say that +1 is gonna move it?
to the left.
Left, how many?
1.
So you're gonna move every dot there, left 1. Left 1, 1, and 1. Okay, so that's what the +1 does. Moves it left 1. Okay, what's the next number that we're gonna look at? Yep.
Horizontal shift, right? Or horizontal stretch, sorry.
Nope, there's no horizontal stretch in
So
that chart.
then it'd be vertical stretch. Right?
Vertical stretch. Yep, that's the next one. So I'm gonna do that one in green. So that's a vertical stretch by a factor of 2. Which axis is the vertical axis?
Vertical is y.
Y. So vertical stretch means all the y values, in this case, get doubled. Where would this point end up if you doubled its y value?
-6, 0.
So right now it's at -3, 0.
So it ended up at
Which one is the y value?
Oh, it ended up at -3, 0.
It would stay right where it is. How about this point?
It will also stay where it is, its y value is 0.
It would stay where it is. And
The last one.
Logan, if I looked at this last point, where would that one end up if I double its y value?
It would end up, up, double.
-1, 4.
It would end up at -1,4, because right now it's at -1,2. So when you stretch it by a factor of 2, it doubles its y value. Now it's up here. So if you look at the picture in green, it should look like I stretched it out now from the black one. Well, from the red one. Stretched it out. All right, and the last one. What's this -3 going to do?
It's gonna move to the right.
So the +1 was the left and the right. So we already did horizontal
Oh, we're
shift.
moving up.
Up and down.
Up and down. And which way is -3?
Up or down? I don't remember.
Is it +3 down there?
It's -3.
So down.
Down. So every point goes down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So the one in blue, that's the final answer. If you do those 3 transformations, that's what you get.
I missed just one thing. How did you figure out which one you stretched out?
The vertical stretch,
Yeah.
that's when you multiply by a number in front.
Yeah, I know that, but how do you know which point to stretch out?
All the points get stretched up, and it's the y value of the point. All the y values got doubled.
Okay.
But some of the y values
Oh,
were on
they
the
were
axis.
0?
Yeah,
Okay, I was like, I only see one of.
yeah.
Okay, that makes more sense.
If the point is already here and you double the y value, it stays right where it
Okay.
is. Yeah.
Thank you.
Yep.
After you put the homework up, could you put the chart back up so I can just copy that all down one more?
Yep. And put the, I can do both.
Alright,
But the chart's on the left if you need it. And then the homework,
Do you,
I think it's like 12
email?
questions or so.
Do you have to email it to you by a certain point, or is it for the whole week?
So that'll be due next time I see you on Monday.
Okay.
So that's November 16th, September 16th.
Okay.
Right, so page 66, those 12 questions, 1 through 3, 6, 8, 13, 15, 32, 40, 44, 57, 63. Okay, again, if you have any concerns or you're having a little bit of trouble with some of the material, let me know, because we didn't have a test this week, so there's no real gauge at like how well you understood what was going on in chapter 1. But when we get to chapter 2, I'll have an idea of what's going on, so I want to make sure that you know what's going on before I test you on what's going on. All right? So come see me if you need any help, or send me an email, and I'll be glad to help you out.